Hi everyone, Flavio here, and I'm going to present this article entitled An Innovative Method to Extract Data in a Real-Time Data Warehouse Environment. This article was written by me, Flavio de Assis Vilela, and my PhD professor, Ricardo Rodrigues Ferre. Firstly, I'll present an introduction and a slide comment about a traditional DW and ETL process. Later on, I'll present a new trends and demands of a real-time data. After that, I present an innovative method to extract data in a real-time data warehouse environment called Data Extraction Magnet. That is why we're here to present this main goal of this presentation. Finally, I'll present experimental test and conclusions. Firstly, I will talk about the two main components that compose the whole data warehouse environment. The first one is called operational environment, that is composed of heterogeneous data sources and systems. This environment is also composed by a group of users that insert data that perform insert operation into these heterogeneous data sources. On the other hand, we have the data warehouse environment that is composed of tools, algorithms, and technologies, and also is composed of a homogeneous and integrated repository called data warehouse (DW) or DW. This data warehouse environment is focused on a decision-making process via OLAP queries and reports. The DW repository needs to be updated from operational data sources in a predefined moment. That is, we need to send operational data that is produced from operational data sources into the DW repository. To do this, for these purposes, we have here the ETL process: extract E, transform T, and load L. This updating process of DW is performed by this ETL process and is performed in a predefined moment. But in recent years, a new demands and new system has emerged, and these emerged systems need to have updated data as fast as possible. These new types of environment and systems, I can example here healthcare systems, road traffic systems, smart farming systems, smart city systems. All these things is mainly composed by this environment. These systems is composed. The data is produced by sensors, and in this sense, the sensor produce a lot of data. A huge volume of data, and that is why we need to investigate a new demands and a new requirements of this environment. By means of a systematic review, we can discover these three main requirements of real-time environment, that is availability, scalability, and low response time. These three main requirements is introduced into the real-time environment, and all the methods, architectures, and other types of studies about ETL process in a real-time needs to consider these three main requirements of a real-time environment. As the days go on, many attempts to perform a ETL process in a real time has emerged. I can example here two main approaches. The first one is near real time and on demand. But even so, it is not enough to perform a ETL process in a real time and meet the requirements of real time environment. This is because is an implicit overhead in an operational data sources that is used by a group of users that inserting data into these heterogeneous data sources. And on one hand, and the other hand, we have another group of users that is used the DW repository by OLAP queries. And in this time, we have an overhead into these two environments. And that is why we're here to present the data extraction magnet, a new and innovative method to the extraction phase of ETL process in a real-time data warehouse environment. And so, in this method, we introduce a lot of concepts that different from previous work, never had been used into real-time ETL process concepts. The main idea of our method is the coupling ETL process and operational environment. We have today, nowadays, currently, we have the following characteristics. The ETL process needs to access and directly access the data warehouse, the operational data sources and get the data. And to the coupling, the ETL process and operational environment, we introduce here the concept of tag, data or data of interest. Data of interest or tag is just is an indicative that a data that is produced from operational environment will be used later on into DW repository. This data of interest is target to a tag named, for example, student, for example. And in this sense, we can assign this tag student into a data from operational environment that is produced into a operational data sources. By doing this, we can reach the following two concepts, the following two characteristics, that is non-intrusive and reactive. By using the tag concepts, we cannot need to access directly the operational data sources. We can receive this data from operational data sources, and now we have this data extraction magnet dealing with all this data that is produced into the operational environment by means of tag. And in this sense, we don't need to access directly this operational environment, and we cannot be intrusive. That is, we can be a non-intrusive method. And in this same way, we can reach the next concept, that is reactive. Once data is received from data extraction magnet, we can react automatically to this received data and directly redirect this data to this data warehouse of interest. We can reach all these things by means of metadata management, by means of metadata, and we can reach the sharing of data of interest that is produced in an operational environment, and make this data available in a DW environment. We can reach these characteristics by means of a publish-subscribe systems. Why does we use this publish-subscribe systems? These systems is just to allow us to share data from one environment, heterogeneous environment, to another heterogeneous environment. It's just to do this. Okay. This next figure, we can show the architecture of data extraction magnet method. To better explain this figure, I first I started here in a management environment. This environment is composed by two main repositories: tag repository and sources repository. In this repository, we can configure the tag, the name of tags that is used to be assigned to an operational environment, to a data from operational environment. And in this another repository, we can assign a tag that is stored into this repository, tag repository, and assign this tag and the data from operational environment. Once configured these two repository, we can make data extraction magnet operated in a React operate this whole process by means of metadata management. In this other component here is operational environment that we illustrate a lot of sources: source 1, source 2, source 3, and so on. After that, we have the PubSub component, and we have here the data extraction magnet. This whole things is composed of listener, validate, buffer management, and these all things that is composed the data extraction magnet. Why does we use these PubSub components? As I said, these components just to allow us to send data from operational environment and the A2L process. And to reach these characteristics, we use the Mosquitto PubSub. That is a service that is available from Eclipse. And in this other side, we have the data extraction magnet. Once configured this metadata, data extraction magnet is composed of a listener component. This component is directly connected to the broker, PubSub broker, and is ready to receive data sent by the operational environment. Just to recap, this operational environment needs to connect to the PubSub broker and is ready to send data from this broker. At the same time, we have the data extraction magnet by means of listener components connect to this same broker and is ready not to send data but to receive data. Okay, and once once operational environment send a data to PubSub components, listener is ready to receive. Once receive this data, these listener components send this data direct to the validate components, and so this validate component is responsible to connect into the repository that is a relational databases to validate this data that is just to receive from operational environment. This validate process is just to seek for a tag that is configured and this tag, and what is the tag that is assigned to the data of interest that is sent from operational environment. Once validated, this validated data is stored into a buffer management. This is because the next time this same data is received from the listener, from the data extraction magnet, we don't need to directly access again this repository to make the validation. to do this, by doing this strategy of buffer management, we can minimize the access to the repository, to relational repository, and this characteristic can increase the performance of data extraction magnet. And the next time that this data is received, we can seek for this tag into the buffer and not into the repository, okay? And once validated data, we can store this validated data into these components called send data. This component send data is ready to send this validated data into these components, okay, and is ready to send this validated data to the next phases of ETL process. As you can see here, in this moment, we have data of interest that is produced from operational environment and a tag associated to this data. And as I will say, as I will talk about in the conclusion, this send data, this validated data is ready to be sent to the next phase of ETL process, and I will present the future works that we are working now just to send data, this validated data, to DW repository, DW of interest repository, because we have here a data of interest. But on the other hand, on the other side of DW, the data warehouse environment, we can normally send this data from DW repository, the DW data warehouse of interest. We can use the same concepts of data of interest in the data warehouse environment, that is data warehouse of interest. Okay, and just to comment here, this repository, this tag and sources repository needs to be configured just one time by the administrator users, and and later on the data extraction magnet can be performed all these tasks automatically. Okay, and to validate this data extraction magnet, that is our developed method to extract data from operational environment. We made an experimental test in a dairy farm domain. It was driven synthetically by a data that is generated synthetically by a synthetic data generator systems. This synthetic data has the same properties of a real-time data, for our real data. This data that we can reach, that we can find in a real time, in a real case of a dairy farm domain. But by using these synthetic generator data systems, we can control the volume and the frequency that the data is generated. After this experimental test, we can validate the requirements of a real-time environment, that is availability, scalability, and low response time, and we validated the performance of data extraction magnet against the performance of trigger technique. We can consider after we made a systematic review, we can find a lot of works, a lot of studies, a lot of methods, a lot of architecture, and so on, and we can realize that a trigger technique is considered as a state of the art of the extraction phase of the ETL process, and that is why we use this experimental test to validate the data extraction magnet against the performance of data extraction magnet against the performance of trigger technique, the state of the art. Okay, and in the next three graphs, we can see the results of the experimental test. Firstly, we have here some measurements that we used to measure the data magnet and trigger technique, data extraction magnet and trigger technique. This graph is composed of these measures, six measures, mean, P15, average, P95, P99, and max. Okay, the blue, dark blue, is the data extraction magnet, is an indicative of data extraction magnet, and a light blue is an indicative of trigger technique. As we can see here, for the average, for example, just to comment here, this first experiment is composed of 32 sensors sending data from 2050 calls parallelly. Okay, continue here. As we said, at the average of data magnet is about 0.529 seconds. All these numbers represents the response time in seconds. Okay, and continue here. The average of data extraction magnet is 0.529 seconds, and the average of trigger technique is 3.873 seconds. For example, here P99 for data extraction magnet is 1.285 seconds, and this same measure of trigger technique is 12.43 seconds. Okay, as we can see here, the performance of data magnet is better than trigger technique for this test. Another test that we made is here, the graph 2, 63 seconds, sending data from 500 of calls parallel. Sorry, I make some confused of 1,100. Okay, sorry, and 500 of calls parallel. Okay, we have here the same measures: mean, P50, average, P95, P99, and max. For the average of data extraction magnet, we have here 0.859 seconds, whereas the same measure of trigger technique is 5.73 seconds. And let me see here, P99 of data extraction magnet is 13.028 seconds, whereas the same measure of trigger technique is 20.071 seconds. And as we can see here again, the data extraction magnet can reach a good performance and can be a good a good performance gain against trigger technique. And lastly, we have here the graph 3, 125 sensors sending data from 1,000 calls parallelly. As we can see here, again, the trigger data extraction magnet, for example, in P50, can reach from two data extraction magnet can reach 0.5 471 seconds, whereas the same measure of trigger technique is 1.913 seconds. The average is the average to data extraction magnet is 0.5 to 9 seconds, whereas the same measure of trigger technique is 3.873 seconds. To finish here, P99 of data extraction magnet is 1.285 seconds, whereas the same measure of trigger technique is 12.43 seconds. As you can see here, data extraction magnet could reach a good performance and a great performance gain against trigger technique, and as we can see here, the scalability, availability, and low response time of data extraction magnet can be reached, and we can extract data from operational environment by respecting the three main requirements of a real-time environment, that is scalability, low response time, and availability. Okay, and to finish our presentation, we can do the conclusion. We develop a new and innovative method to extract data from operational environment. To do this, the main idea is the coupling ETL process and operational environment. For these purposes, we use the following concepts: tag, non-intrusive, reactive, metadata management, publish-subscribe system, buffer, and parallelism. And all these things together by using all these things together, we can reach a good and a great performance, as you can see here from the experimental test. A great performance gain of a data extraction magnet against trigger technique, and a great performance in scalability and low response time of data extraction magnet. And for future work, we intend to extend this performance test, as we said later. We intend to extend performance test in a real case study. We intended to build an innovative way to store data of interest into a target data warehouse, as we said later. And firstly, we intend to investigate another metadata to be applied into context of stored data of interest into a target data warehouse. Okay, and all these things we can reach the whole ETL process in a real-time data warehouse environment. Okay, and that is all for today. Thank you for your time. If you need further information, feel free to contact me at flavio.vilela@ifg.edu.br. Okay, thank you for your time. Bye.